Welcome to our live presentation, ladies and gentlemen. This is live broadcasting, and we are not broadcast professionals, so I apologize for that. But we are AFP professionals, and so we're happy to show you our equipment. We're going to do our best today. We're going to do some dry fiber, which you've probably never seen our equipment do, and we're going to do some pre-preg as well. We're going to head out and look at the head, and Charles is going to talk about that, so here we go.
So this is our half-inch 16-toe head. It's a modular heads with different material form factors really quickly, and go to work with any different material, drop it off when it's empty, pick up the next one super quickly and easily. Another feature of this head, which is kind of on all of our heads, is we've got an open and simple toe path. So it's really easy for the operators to thread and reload material. The material spool is here, thread it through down into the business end, and the operators are able to do that on our heads as quickly or quicker than any other head in the industry. We've kind of got a modularity of components on the head, so we emphasize that everything that the operators and maintenance personnel interface with be as easy as possible to remove and replace. So just for one example of that, a compaction roller, comes on and off that quickly, and that's kind of a feature throughout the head. Two of our newer features that we've added are our servo-controlled creel. So the material spools here are servo-controlled, which gives us really good process control as far as the tension that we have during layup, and it allows us to do some really cool things as far as accuracy of end placement and also inspecting the end placement in process. And kind of the last point to touch upon is this heater here. So it's a new heater topology for us. It's a variable spot size laser heater, and what's really cool about that is it gives us individual toe-by-toe control of the heat. So, if you're going through doing a staggered add, you can turn the heat on for each of those toes one by one, which is a major improvement over kind of the old, which was these single infrared emitters that would heat up the whole toe path at the same time. And that allows us to get really high quality out of our layups. That's pretty much it.
Okay, sorry folks, I did. Quick check, mic is working? Okay, good. All right, so I'm going to show you the dry fiber first. This is got no resin in it. It's very fluffy and dry fiber. And on this side, you see it's a little shinier. It's hard to, oh, there we go. Yeah, there you go. You can see it there. So you can see these three are not shiny. This one is shiny. The shininess is as a thermoplastic veil, they call it, and that's how you stick the dry fiber to itself later on when we do the layup. This is, and again, that's Solvay TX1105. And here we have the Toray. I think the best stuff on earth, but who knows, maybe there's better stuff. Toray 3900. This is an autoclave based thermoset pre-preg. We can really lay this stuff up fast and reliably. So we're big fans of it, but we're always looking for others. While the machine's going here, it's laying up the pre-preg.
Takeoff.
Okay, so while the machine lays up, I'll discuss what's going on. If you could see the graph, there's a little graph there. What we're showing is the feed rate. You can see the machine's extremely fast. It's doing layups at 3,000 inch per minute. And then later on, we're going to get up to 4,000 on the longer courses. They're coming up. You'll see the 4,000, it peaks to 4,000, it slows down to 3,000 to make the cut. So the ads are 4,000, traverse 4,000, cuts at 3,000. There's a lot of math and reasons why we have to cut at 3,000 these days. Okay, so the layups, we just did 3 layers. It's actually a very complicated layup because it's got really short toes, got some gaps, and we're laying up very fast. Let's go out and look at the layup. Here we go. All right, well, welcome to our laser safe room. This is the AFP lab where we do our work. I'm not going to point out much because there's not much to see here. This is a really good looking laminate. I'll let Charles talk about the details.
Yeah, so a couple of the big things that our customers look at when they look at quality of a layup. The first would be the accuracy of the end placements here with respect to the ply boundary, which is where they're programmed and designed by the engineers. So, you know, the servo creel, like I mentioned before, is one thing that allows us to get really high accuracy there and also to inspect it in process. So you'll see that in just a second. But, you know, you can kind of just see offhand that these are lined up really nicely. So we'll get into that with our automated inspection system in a moment, but just, you know, looking at it, you can kind of see we've got really nice smooth lines here, no like late toes that you can see or anything like that. So that's one thing that our customers look for. The other thing is if we look at the tack that we've got here, you want to make sure when you're doing AFP that you don't have untacked toe ends either on the ad or the cut. And so, you know, if we kind of just check it out, this is pretty difficult to tease up. So, you know, that's exactly what our customers are looking for to make sure that they don't have process issues with subsequent plies, either pulling the material of this ply up or folding the material over as it goes over it. So this will give you good consolidation, good part. And so, yeah, that's kind of the quality aspect. And now we'll go over and look at the actual inspection that we took in process.
All right, I guess it's my turn to talk again. We'll go over to the inspection system. Okay, I'm going to talk about the inspection system while Charles sets up to run the dry fiber. Mike's going to help me out here. He's going to queue up the latest inspection file. And that's what it looks like. You can see the laminate that we just made, and he'll enable the toe end so you can see where we captured the toe ends and zoom in on that. Okay, so cool. So what you're seeing is where the system calculated the toe ends landed. You know, some of them aren't exactly on. Well, that's the reality of AFP. Mike, why don't you show us the report so we can see how well or not they were done. Okay, so the aggregate of the data is really good. The average toe error was 9 thousandths of an inch, with a standard deviation of 55 thousandths of an inch. Sorry, I don't do millimeters on the fly like that, but you can see we're well within limits. The limit for standard deviation is 150 thousandths, and the limit for the average is plus minus 150 thousandths. So a very good looking layup. What's happening right now is we're doing something a little strange. We're laying dry fiber on top of thermoset prepreg. I don't think you would ever do this. We're just doing it to lay a base layer, so then we'll do dry fiber on top of dry fiber next. In fact, that's why we started out late, is we were trying to figure out what was going on there. And while he does that, I'm going to go ahead and talk about this thermoplastic layup that we have here. So we don't just do dry fiber and thermoset prepregs, we also do thermoplastics like this. And you can see this is a 1/4 inch thermoplastic material. I'm not sure which one it was, but it's an interesting layup. We've recently started doing testing for porosity and crystallinity on our layups, and developing our process so that it's going to be production capable soon. Obviously we're making good parts now, but we're dialing in that last 0.5% on porosity and really getting this process dialed down. And yeah, we're going to go to standby for just a minute. Apparently there's something going on with the interface layer, which isn't completely unexpected. So give us 1 minute. Okay, we're back. Sorry about that. So dry fibers, new technology, and every now and then we have a hiccup. We had one. That's okay. We're still going to be able to continue, no problem. Charles has to change a laser parameter because it's different for dry fiber on dry fiber than it is dry fiber on prepreg, which is a really odd thing to do. We're now going to go dry fiber on dry fiber, and I think we'll have a video feed of the machine here in just a second. Okay, so just so you know, we're doing DFP Solvay TX1105 back to the machine. On. Okay, so the machine automatically finished the first ply. That's what they do. The inspection system verified that every toe was there and it was accurate enough, and so it continued on to the next ply. We're going to do 2 plies of DFP. It's a little riskier than the thermal sets. Like I said, it's a new material form, and everybody's learning, the DFP maker and us, but I think you'll like this layup anyway. Here we go. Okay, so the lamination's done. That was DFP on top of DFP. Let's go out and look at it. I'm sure you're curious to see what that looks like. Obviously saw the layup part looks very much like thermoset prepregs, but of course this is a dry fiber with the thermoplastic veil, Solvay TX 11.5. And what's going on here is this is a laser safety room, and this key is the death key. You don't want it in there if that key is in the on position, so he takes it with him, or I'll take it with me. All right, so we're going to look at the quality of the DFP. We did have a little problem when we were doing one of the transition layers that it is a little weird to lay dry fiber on top of thermoset prepreg. That was the only issue we had. We left the tow out because we were in a hurry to get back to you, so we're back to you. Now we're going to look at I want you to focus more on the DFP on top of DFP. And here goes Charles. Go.
Cool, yeah, so we've got 2 layers here of DFP on DFP, and you can see we've really, you know, it looks really similar actually to the prepreg and how well it's tacked here. It's probably going to be a little bit easier for me to tease up, but...
Well, actually you're splitting it.
Oh yeah, yeah.
So the veil is staying on the part, but he's actually splitting the dry fiber off the veil there.
Yep, and you know, you can see the toe ends that I'm not screwing with are nice and tacked. So that's the add side, you know. Go over and look at this cut side. And yeah, you know, well tacked to the part there, you got to put a little bit of effort in to tease it up. You won't really see any difference in the accuracy of our toe end placement compared to the prepreg that we just ran earlier. So yeah, you know, a pretty good looking layup considering that we're going with DFB here.
Okay, well thanks Charles, and that's pretty much it for our show today. I just wanted to show you that we can do prepreg and dry fiber, and we're kind of trying to work out the detailed live broadcasting. You know, we're professional engineers, not professional broadcasters, and I have a face for radio, so here we go. We'll look forward to seeing you guys again. Look for an announcement from us, probably June 2nd, I think is our next AFP 4.0 presentation. Today was actually more of a mixed materials presentation. AFP 4.0 is a philosophy for fiber placement that focuses on first quality, then it focuses on reliability of the process and equipment, it focuses on the performance of the equipment, how fast can we lay it down, and finally, if we can get those 3 right, you're going to get utilizations that's 4 to 6 times what you're used to seeing in fiber placement. So imagine 1/6 the equipment to make the same amount of parts that you're getting today. So I can't wait to see you guys on June 2nd. Hopefully our broadcast is a little cleaner as far as audio visual goes. But man, you couldn't ask for a better machine and a better layup here. So hey, cheers to y'all, and hopefully we'll be all out of lockdown and enjoying our lives here by June 2nd. See ya.